It was there. What was the final score?
It's 62.
What's up?
No, 71 to 68. No, 72 to 68.
Yeah.
All right. So Kendall.
I have a question.
Sure.
Question 20. I made it partway through, but then I had to find the area of the triangular faces. And then I didn't understand.
Okay. So looking at 20, actually, let me do this. This will probably make life a little bit easier on us. This one, I think, right? Yeah. Let me just copy and paste them out of here since they all have these pictures, and I'm just not a good enough artiste to freehand, like a rectangular pyramid, just, out of the blue here. Okay. So you said the volume was fine, right? That's what you're saying? Okay. So just for everyone else's, what did we do? We did 1/3 area of the base times the height. What did we say the height was? 36.05. Yeah, 20 times 20 is 20 squared, right? Same thing. Yep, that's fine. Again, perfectly reasonable question to ask. And Kendall, to get this 3605, did you do this reference triangle, I assume? Okay. So that reference triangle, you would have had this side's 30. This is the side we want. This side you would have had to do another reference triangle to get.
Oh, I guess that might not be accurate.
So that one would have been 20, 20, and then this would be 20 root 2 is what that would have come out to be.
It might not be correct.
So that should be 20 root 2. Let's check that real quick then. Square root of 20, let's just parenthesis, 20 root 2 squared, oops, I should do 30 minus, or 30 squared minus, right? So that should be 10. Okay. Is everybody okay there?
How did you use this? Like, where's the point of the
Okay, so let's just, oh, that's not the right, so this one is the green one. But this one should just, this should be 10 then, right? Because it's only half of that side. My apologies. Is that okay, Kendall, now, or no? Okay. What's the whole hang up here?
So we had our first triangle, but we were missing the bottom, so we went somewhere else for that.
Yeah, so for this triangle, we have the 30. We're looking for this side, and we didn't have that side either, right?
Yeah.
So what I did is it's like, okay, well, if I know the green triangle, this side on the green triangle is going to be, half of that is going to be this side. Does that feel okay there?
Yeah, so could we have done like
Well, we don't know any angle measures. So you could find angle measures if you wanted to, but I don't think that's going to make life any easier. You do know it's a 90-degree right triangle, yep. So you can use the Pythagorean theorem, and you could find the angles, but I don't know that that's really going to be that helpful.
How did you end up getting 26.5? Like, how do you do it? How do you find the angle for the side lengths without just? I thought you said we didn't know.
No, both those triangles are 90s.
Oh, we're looking for the sides now. Okay.
Yeah, we're looking for sides, not angles, right? Okay. We're okay though? Okay. So you would go ahead and grind that through, and that should come out to be your answer. Just for the sake of argument, let's just kind of check that real quick. So we have 1/3 times 20 squared times that guy, which gives us 3527.7, which is the answer that we're looking for. 3527.68 centimeters cubed. Okay, we're good there? Okay. So the surface area is going to be the base plus 4 times the triangular side, or the triangular faces. Okay with that? So the area of the base is easy. That's 20 squared, right? Okay. The triangular face then, if we kind of draw that, this is ABV, for example. So we know this side is 20, and we know that these edges are each 30. Okay there? Okay. And this then is going to be the height for that triangle. And because this is an isosceles triangle, when I draw that angle bisector in, it also bisects that opposite side. So I can use the Pythagorean theorem to figure out that side h then. Okay there? So we'll type that in real quick. Okay, so that's 28.8. So the area of my triangle then is 1/2 the base times that height. So if I do that real quick, 1/2 times 20 times that previous answer gives me 282.8. So here I'd have 4 times 282.8. So my answer then is 20 squared plus 4 times that previous. So I should get 1531.37. Okay with that? So this was a good question, right? There's kind of a lot going on there. Kendall? 27 as well? Sure. Let's just take a look at what that is. Okay. I apologize here in advance that the numbering doesn't hold up for us. Okay. Okay, so for the composite shape consisting of a hemisphere with radius 40 and a right cylinder with the same radius and a height of 140, calculate the volume. So my plan here, it's going to be the volume for the hemisphere plus the volume for the cylinder. Everybody okay there? If I look up the volume formula for the hemisphere, it's 2/3 pi r squared. If I look up the volume formula for the cylinder, it's pi r squared h. So I have everything I need given to me in the problem because the radius is 40 and the height, oops, that was an r cubed, excuse me. Wrote the formula down wrong. The radius is 40 and the height is 140. So there's everything typed in. I just need to now get into my calculator and get a decimal. So I have 2/3 times pi times 40 to the third power plus pi times 40 squared times 140. So that gives me that monster number there, which is what, 837,758.04 centimeters cubed. Kendall, are you okay there? Okay. So my surface area is, you might think, is going to be the surface area for the cylinder plus the surface area for the hemisphere. But that's not quite right. The reason being that when we place that hemisphere on top of the cylinder, one of the bases for the cylinder is covered by the hemisphere. So I'm going to also subtract off that one of the bases for the cylinder. I am going to do that. Maybe I'll write hemisphere, no base there. But the cylinder also loses a base in the process, right? Okay. So that's going to be just one base, which is pi r squared, plus pi r h, plus, is it 2 pi r squared? I forget the formula. I'd have to look that up real quick. I'm disappointed that nobody remembers. That's the area formula, or the volume formula. We want the surface area here. It is 2 pi r squared. I was right. Okay. Everybody's good? All right. So just plugging things in then. Pi times 40 plus pi times 40 times 140 plus 2 times pi times 40 squared. Oops. Pi times 40 squared plus pi times 40 times 140 plus 2 pi r squared. And that didn't match the answer that I had written down in the textbook. Oh! This is 2 pi r h. Great googly moogly, Mr. Kulik. You really made a goofer out of that. There we go. I was like, what's going on? It's because I didn't remember the formula right. Well, it's a good thing, what, for you guys? Yeah, you get all the formulas on the test, so you don't have to memorize them. You'd have to know what the letters mean. I mean, I think so. I mean, you can look at I've posted the review. If you look at the equations at the end of the review, that's the same equation sheet you'll get for the exam. I think it's pretty comprehensive. I haven't looked through it like carefully in a year or so. But my intention was not to leave anything off, but just so when you're doing it, like I would look at that, and if there's something that's missing, that's your responsibility. But I think it's pretty comprehensive. Yeah, you're welcome. Angelina. Of course. You're welcome. Kendall. Satisfied with that one?
Yes.
Okay. Who else or what else? Danny. I mean, I put them on the homework. Do you want to do one of them? Okay. Do you have a preference? Should we just do the first one?
Yeah.
Okay. So, 31. Again, pardon the numbering. So it says a shipping containers to be made with 6 rectangular faces as shown in the diagram. So just a box. It says the dimensions are, the length is 2x, the width is x, and the height is y. Everything's in meters, and the total length of all 12 edges is 48 meters. Show that y is equal to 26 or 12 minus 3x. So this is how we're going to get that. So how many 2x sides do I have in this picture? 4. Yep. Is everybody good with that? How many y length sides do I have in this picture? 4. And how many x length sides do I have in this picture? 4. And that should all add up to give me 48 then. Okay. So 4 times 2x is 8x, and plus another 4x is 12x. We good there? Now, if I look at what I'm trying to get to, I want the y by itself. So I'll just subtract the 12x over. And then I'll divide both sides by 4. Oops. And that's what I was looking for, right? So your work shouldn't be those kind of 3 steps there. That's what you'd need to do to show that. Does that feel okay? Okay. Next thing it says is to show that the volume of the container is given by yada, yada, yada. Okay. So what's the formula for volume for a box? Just length times width times height, right? Okay. So that's going to be 2x times x times y. So far, so good. But notice in what we're trying to show, do we have any y's in there? No. But if I use the previous solution, I know that y is the same thing as 12 minus 3x. So if I replace y with 12 minus 3x, and I multiply the 2x and x together to get 2x squared, I'd have this then. We okay there? And then if I just distribute through the 2x, 24x squared minus 6x cubed. So for that answer, the work that I'd expect to see are those 3 steps. Is that okay? Sure. This would be as hard as it would get. Be as hard as it would get. Okay. Find the value of x, which v is maximum. This is a problem that I would use my calculator, because I know that v is equal to 24x squared minus 6x cubed. So I'm just going to plot this on my calculator and look at the picture. So I'm going to go into my y equals menu, and I'm going to graph 24x squared minus 6x cubed. Okay there? And then I'm going to graph this on a window. So remember, x is one of my side lengths, right? In fact, my length is 2x and my width is x. Since it's a side length, it can't be negative. That doesn't make any sense. And since my side lengths have to add up to be 48, and one of them is 2x, the longest that x could possibly be is 24, right? So I'm going to graph this in my x's from 0 to 24. Those are the only x's that are feasible solutions, or feasible side lengths for this thing. So I know it has to be in between there, what I'm looking for. And the volumes, I don't care about it being negative. And I don't know how big this could be, so I'm just going to put something like at 1,000 down there. I don't really know. If I have to make that bigger to see the top, I can make it bigger, but I'm just taking a stab in the dark right now. Feel okay? Let's hit graph and take a look. Okay, so that's the highest point, right? So I'm just going to find that point now with my calculator's help. To do that, I can press second and the trace button. And the command I'm going to use is the maximum command. To use I need a better picture than this. I'm just going to do that. It's going to be too hard to see what's going on. All right. So I just changed that to 100 because 1,000 was clearly way too high. All right, so I did the maximum command. Now down at the bottom, it's going to ask me some questions. The first question it says is left bound. So all I'm going to do is I'm going to move my cursor until it's on the left side of that highest point. There's my cursor. So that looks good. Then I ask for right bound. I'll do the same thing. I'm just going to move my cursor somewhere to the right of it. Doesn't really matter where as long as it's on the right side. I'll press enter. And then a guess. Doesn't matter where you pick a guess. So it comes out to be x is 2.6 repeating. So like 2 2/3. Seems good. Or really you could call this 8/3, I guess. Whatever. Feel okay there? For I, this is x. Oh, sorry. Yes, sorry. I get what you meant there. So x is 2 2/3 or 8/3 or whatever. Okay. So then it asks for the volume. Well, all I'm going to do then is take that equation for volume and plug in 8/3. Or I can read it off my graph here. So when I found the maximum, the y coordinate is going to give me that maximum volume, which is 56.89-ish. And I think we said these were centimeters. So that's volume, so it's centimeters cubed. Okay with that? And since we know the value for x, I know the width, right? And since the length is 2x, I know the length. I just multiplied it by 2. And since the height is y, and y equals 12 minus 3x, I can just do that on my calculator. 12 minus 3 times 8/3, which just gives me 4. I guess these are all centimeters, I think. Or whatever the units were. Oh, meters is the unit. There. Does that feel okay there? Still okay? Part L says the container is to be painted. 1 liter of paint covers 15 meters squared. And paints come in tins containing 4 liters. Okay. Calculate the number of tins required to paint the container. So I need the surface area. So that's just going to be 2 times length times width, plus width times height, plus length times height, I think is the formula there. So that's going to be, I'll just do it in the calculator, right? We wrote down what it is. So we have 2 times 8/3 times 16/3. Ugh, thank you. Plus 8/3 times 4 plus 16/3 times 4. So that's 92.44 meters squared. Okay. And I know I get 1 liter of paint for every 15 square meters. So if I divide this by 15, that'll tell me the number of liters of paint I need to have. Divide that by 15. So 6.16. Can I buy 1/6 of a liter? No. So I should round this. Should I round it up to 6 or down to 6 or up to 7? You have to round it up to 7. Because you have to have enough paint to cover it. If you have some leftover, you have leftover, but you have to have enough. Everybody good there? And then I know that the tins contain 4 liters. So if I divide this by 4, that's going to give me 1.75. But really, I have to round that up to 2 tins. That was the whole problem there. The nice part was none of those steps were particularly long, right? And they all just kind of like helped you do the next one. Well, not necessarily, right? Because if maybe I didn't know how to do G. But notice the only thing I needed to do h was the answer for the value for y, which I have in g. So even if I couldn't do g, I could have still done h, right? Notice in I, all I needed was this value or this equation for the volume, which I had in part h. So even if I couldn't do h, I could have still done I, right? Now, obviously I couldn't do j without I. That's true. And I couldn't have done k without my answer for I and j, or I specifically, right? But you could do a lot of this, right? They're like these ones that seem like they're built on the other, maybe aren't as built as we think they are, or you can just use the result from the previous, especially for the show problems. You can still use that even if you didn't get the show part, or if you weren't sure what to do to show it. You can still use that result on the next question. It's okay to do that. Does that make you feel a little bit better? Meh.
This is a lot, and like all the formulas are the same, obviously, but when you have like all the different numbers and then your brain kind of like process how to put them together.
Yeah, no, I understand. Like this is particularly an area where like kind of some neatness and organization helps. Like labeling things well and making sure that you're like labeling what number is what. Like, is this a length or a width or a height, or what did I just find here? And all that, I think, certainly is a bit of a challenge, right? But going slow and making sure you have the right values and the right formulas is kind of the trick to being able to handle one of these. Yeah, so what we did to graph this, basically we graphed y equals this. We used the variable y instead of volume. Yeah, and just found the highest point on the graph. Which, again, like, that's all I would expect you to do with that. Okay? I won't have something this hard. Shh. Do you want to do some more of these? Do you just need a chance to practice on stuff on your own? Okay. So we'll stop here. You guys can take the remainder of our time today